everyone. In this video, we will be talking about scientific notation. Our essential question for today is, how is scientific notation used to write very small or very large numbers? So once again, how is scientific notation used to write either very small or very large numbers? So first, it's important that we go over the difference between scientific notation and standard notation. Standard notation is the normal way of writing numbers, so it is the way that you are used to seeing numbers, such as 350, 40,130, or even very small decimals. So this is the traditional way of writing a number that is probably very familiar to you. Now, scientific notation looks a little bit different. Scientific notation is a way to write very large or very small numbers, and it's a way to just kind of save some time if you're, again, writing some very large or very small numbers. Now, the way that this looks is that you've always got a coefficient right here. So your coefficient, and it's being multiplied by 10 to some power. If it's a larger number, it's going to be a positive exponent. If it's a decimal, it's going to be a negative exponent. Now, this number, the coefficient, will always be between the numbers 1 and 10. It always must be a single-digit number to the left of the decimal. So that means something like it could be 1.4 or 5.3, 7.2, but it could never be anything larger than 10. It couldn't be 10 because that's 2 digits. It couldn't be 11. It couldn't be 100 or 52.3. It could not be any of those numbers. It must be a number between 1 and 10. All right, so let's talk about how to change from standard notation into scientific notation. Now we've got a few rules here, and I'm going to go through these rules as we go through a practice problem. So if you're given a problem like this, 390,000, and we want to put it into scientific notation, we know that there's going to be some sort of coefficient, okay, times 10 to some sort of power. Okay, so we know we've got some sort of number, a coefficient, times 10 to some unknown power. Now your first step is to move the decimal in the number until you have a coefficient between 1 and 10. Now the best place then would be right here, and sometimes I just draw a line to separate it. And if I put a decimal here, I have the number 3.9. And is that between 1 and 10? Yes, so I know that my number that's going to be over here, that's our coefficient, will be 3.9. Now I'm going to keep all those zeros after it for now, because what that's going to tell me is what our exponent up here is going to be. So our second step says count how many digits are to the right of the decimal point. So if I look right here, I've got 1, 2, 3, 4, 5 digits to the right of the decimal point. So then what I know with this is I know that my coefficient is going to be 3.9. I know I'm multiplying by 10. And since it's a larger number, it'll be positive exponent. And since there are 5 numbers to the right of the decimal point, it's going to be to the 5th power. Okay, so to the 5th power. And that's our answer. And we can just drop the zeros after the 9 after that, or else you're basically just writing a really, really long number. That's the same thing as writing it the way that you see it right here. All right, let's look at a few examples. So what if I had a number like 598? That can actually be written in scientific notation, even though it's not a very long number. Now, the way that we would do this again is that we would draw a line between it to make a number between 1 and 10. So we know that the decimal point will be between 5 and 9. So for now, our number is going to look like 5.98, but we know that overall our number has to look like some sort of coefficient times 10 to some unknown power. Okay, so we got to figure out what those are. So right now we know that 5.98 is going to be our coefficient, but to what power is it going to be? Well, how many numbers are to the right of the decimal point right now? There are just 2. So that tells us it will be 5.98 will be our coefficient times 10 to the second. Now let's try one with a smaller number. Okay, so we need a number between 1 and 10, and that number will be 3. So 3.13 would be between 1 and 10. So for now, I'm going to move the decimal there, but I'm still going to keep all of those zeros so that I can count how many digits are to the left of the decimal point. When it's a larger number, the numbers are to the right of the decimal point. But in this case, since we're talking about a small number, it's to the left. So we know 3.3 will be our coefficient that goes here, times 10 to some sort of negative exponent this time, since it's a very small number. Now the question is, how many numbers are to the left of the decimal? And there is 1, 2, 3, 4, and 5, which means we will get 3.13 times 10 to the negative fifth power, this time since it's a small number. And that's all you do. But let's look at a couple more, just to make sure we really understand this. Okay, so again, we know we're going to have some sort of coefficient times 10 to some power, and we have to figure out what both of those are. To make our number between 1 and 10, I can just draw a line here for now, and 8.64 would give us a number between 1 and 10. And I'll keep the zeros after it so that I can count those, because I need those numbers to tell me how big is our exponent going to be. Because this time it's going to be a positive exponent, since we're talking about a large number that's not a decimal. And there are 5 numbers to the right of the decimal, so we know our exponent will be a 5. So now we can just drop these zeros and write it as 8.64 times 10 to the fifth, because 5 represents our 5 numbers to the right of the decimal point. And let's do one more. Okay, so 0.238. Again, we want to make this to a number between 1 and 10. And if I draw a line right here, that number will be 2.38. Now, for now, you can see how many times did I just move the decimal? I only moved it once. Okay, so that's important to note that even though there's a 0 here, that 0 didn't have a decimal before it before. Okay, so we really just moved the decimal place once. So we've got 2.38 is our new number, so it became bigger. But if we want to write it as something to the certain power, or the 10 to the something power, we know it's going to become a smaller number. So this to here becomes a smaller number. So we can write this as a negative exponent, and we only move the decimal once, and there's only one number behind it. So that gives us to the negative first power. And that's it. Now let's look at a few examples where we go from scientific notation into standard notation. Now, let's go through a few steps. If we have a number like this, the first step is that you want to write the decimal and remove the 10 to the x power. Okay, so we've got 7.7, but we're going to change that to be a much larger number, because this is basically saying if we've got 10, okay, you're saying that you're timesing 10 by itself, oops, that keeps disappearing, 6 times. So on and on and on, 6 times. That's going to be a very big number. So when 7.7 is multiplied by that, this is going to become much bigger. Now, after you have removed that 10 to the whatever power you have, you're going to add a certain number of zeros behind the decimal until you have the same number of digits as the exponent. So I need to have the same number of digits as this exponent, which is 6. So I need to have 6 numbers to the right of the decimal. And to get that, I can just add in some zeros. Now I already had 1 with the 7, and then I added 5 zeros. So now I have 6 digits behind the decimal point. Now what I can do is remove the decimal and write it in standard notation. So I can drop the decimal now, and that means that 7.7 times 10 to the 6th represents 7,700,000. So let's look at a few examples. Okay, so we've got 8.94 times 10 to the 4th. Again, we're going to write down our decimal, and then we need to make sure there is 4 digits to the right of the decimal. Right now we have 2, so all we're going to need to do is add 2 more, and now we've got 4 digits to the right of the decimal. From there, you just drop the decimal, add your comma, and that's your number. Now, could you go through and find out what 10 to the 4th is and multiply it by 8.94? You could. However, since this is to a 10th power, it's very easy because we can just move our decimal places. So really all that you saw here is we took this decimal and we moved it 1, 2, 3, and 4 times. Because technically, if you think about it, this is a decimal right here. It's just got all zeros after it. Okay? All right, let's try one that's a negative exponent. So in this case, our number, you need to find out where is your decimal. So if you have 8, that is the same as 8.0. That's where your decimal is. And instead of having numbers to the right this time, since we're talking about smaller numbers, we need 3 numbers to the left, or we need to move the decimal place 3 times. So I'm going to add 1 and 2 zeros because I've already got an 8. So this is basically saying I'm moving the decimal once, twice, and 3 times. And since I've got 3 numbers to the left of that original decimal, that's the same again as moving it 3 times. So instead of having 8 times 10 to the negative 3, that is the same as a 0.008. Okay, a couple more examples and then we're done. So we've got 8.35 times 10 to the 5th. So again, what we're going to do is write down our decimal, and we're going to add enough zeros behind that decimal to give us 5 numbers to the right. So I need to add 3 zeros this time, and that gives me 1, 2, 3, 4, 5 numbers to the right of the decimal. Once I drop the decimal, I can add in that comma, and our number, it represents 835,000. And one last one. We've got 1.2 times 10 to the negative 4th. That tells us it's going to be a much smaller number, a very small decimal. Okay, so I write down 1.2, and I know that these zeros are going to go to the left this time, and I need to move this decimal 4 times. So that means there should be 4 numbers to the left of the decimal. 1 is already one of them. I can add in another 0. So that's 2, 3, and that's 4 numbers to the left of the decimal. And then all we do is we move that decimal back to the front, and we've got 0.00012. And that is it. All right, you have a couple of practice problems. Give those a try. If you have any questions, let me know, and we will spend some more time reviewing this in class.